Hello all, I am Brian Arenio along with Jacob Sales and Nicholas Kumar. We will be demonstrating vehicle vulnerabilities and performing a rolling jam attack under Dr. Taeb's advisory. A rolling jam attack exploits known operational frequencies for car key fobs in order to unlock vehicles and provide unauthorized access into a personal vehicle. We have implemented this attack to demonstrate the need for vehicles to update replay attack mitigations. Some objectives of this demonstration is to jam the signal from being received from a vehicle, correctly capture the packets from a key fob, filter an interfering signal broadcasted by a jam, and then retransmit that captured and filtered signal to a car in order to unlock it. And lastly, to identify possible mitigation plans. Here is some necessary information to understand the attacks. Rolling codes, they are pseudo-randomly generated and they can only ever be used once in their lifetime. The rolling gem attack compromises the three pillars of the CIA triad, which drive the development of cybersecurity systems and policies. Confidentiality is compromised by snooping, integrity is compromised by masquerading and copying legitimate codes, and availability is compromised by jamming. We will use a yardstick, which is a software-defined radio installed with the RFCat library to implement all aspects of the attack.
So, for our attack, we're going to be jamming a signal specifically made for the car model, which is 314 megahertz. And then we're going to be recording at the same time with another yardstick. Once we capture these recordings, we're going to filter out the jamming noise from the captures, and then we're able to replay those captures that were filtered to then open up the car. So the specific attack captures two codes while jamming, and then it plays back one code and then keeps the other one so that it could play it back later.
Alright, so we'll go ahead and start off with the jamming portion. So we're going to go ahead and start out and we'll be at the 369,000 megahertz range. So that's what this vehicle is transmitting at, as we can see from the spike right there. So we'll go ahead and start the jamming sequence, and that spike that we see a little bit offset from 369,000 megahertz is actually our jamming signal. So as we can see, as I'm pressing the key and trying to get a response from the vehicle, nothing is happening. In our roll jam attack, we're going to be doing a similar thing, so we'll go ahead and engage the jam here. So on the right side, we'll see the jam, and this is where we'll start the replay. This is the second yardstick that we have. So as we can see, every time Brian is hitting the button here, it's capturing packets, and some of this time, because we're in a high transmission zone, it's capturing trash. So we'll drop the key to show that we no longer have possession of it, and we'll go ahead and stop the jam. No more spike on the left side, and we'll go ahead and begin the replay. That replay went ahead and unlocked the car. So as we can see, Jacob goes ahead and unlocks the car, and as we were talking about earlier, because of the high transmission rate, we are capturing trash. So we'll go ahead and let Brian clear out some of the trash from this video, and we'll go ahead and actually get another valid unlock. So right there's that another valid unlock, and as we can see, Jacob opens the door again. And we'll see Brian finish out the code to finish the sequence, just so we get our final message.
So with our first mitigation technique that we discovered is the timing windows. So what this means is that whenever a packet is sent to the car needs to check what time that packet was stamped. If that time is suspicious to the car will then deny the packet, and then it deletes that code from its system. The other implementation we decided to look into is the handshake protocol. And so a handshake protocol would make sure that the connection between the car and the key fob is authentic, and making sure that it can acknowledge. With a single signal replay, we would not be able to mimic a handshake protocol. And then the next implementation would be the constant key fob connection. Constant key fob connections are inherently immune to replay attacks due to the fact that it needs a stream of data that is constantly going to the car. With a single replay connection, this cannot do that. It would only send in one signal at one specific moment in time, thus not able to mimic a key fob.